So there are two situations that once we discuss the controls at different parts, that there are controls which indicates that there are tectonics is one control, the eustacy is another control, and then the base level that basically controls. So what will happen when there are two different kinds of basinal setting? Another is an extensional basinal setting and a cold land setting. In case of extensional setting, this is the shoal line. So you have a increase in accommodation on the basinal side and increase in accommodation in the subaerial side. So this is the subaerial accommodation, this is the subaqueous accommodation, and that basically it is increasing on both sides. But what will happen when you have a cold land situation, and everywhere climate has its own role to play, and the tectonics and eustacy, they do balance in the different rate at different part of the basin. Now in a cold land basin, you have the maximum subsidence that basically you are getting in the proximal part, because that is the load, and the load related the flexural subsidence, that the flexural rigidity and subsidence in the plate that cause the proximal part to the maximum subsidence, that is the maximum accommodation that will be generated. So there are two different conditions that may arise. Though we know there is a uniform role of the tectonics and the eustacy, but basin to basin their relative role that basically will be changing, and that is controlled by the whether you are in an extensional system or in a cold land system. Have you drawn it?
Yes, sir.
Yes, sir.
Now we come on to what is base level and the global accommodation, including both the continental and the middle. The first to go for the base. So when we talk about the base level we basically indicate at different scale, whether I am talking about the global base level or a local base level. The global base level I am referring to the sea level. But suppose from here suppose I talk about Delhi. What is the base level of Delhi? The local base level of Delhi is the Yamuna. So all the streams of the Delhi, or during the rain, all the water that is basically draining finally to the Yamuna. So it is the local base level. But if you see the regional or global base level, again the Bay of Bengal, and that the sea level is also the base level for any stream system that is operating right on the Delhi or in the UP or anywhere. So there is a local base level which is defined by the local lake level, where the local stream system they may grade, but they may grade and become equilibrium with this local lake level, but they are not still equilibrium up to this base sea level. So you might always you should remember in your mind that when I talk about a base level, what kind of base level I am talking about? I am talking about the regional or the local. Actually, the profile which is in equilibrium that comes like this. But in a particular area, I may get the profile like this, and the system is equilibrated with respect to this. That does not mean it has been equilibrated up to this. So this concept that there is a local and there is a regional or global, that is always true for any kind of depositional system which basically guide the sedimentation system in the local level and the global level. Now, when we connect the fluvial and the marine system, these two together, and then try to define the accommodation and the base level, both the concept of the accommodation and the base level, when it is defined from a continental to the marine system, then the total definition comes like this: that you have this entire hemisphere that basically goes like this, and that this is the level of the lowest level of continental denudation. So if the continent that goes into denudation and its continental base level, it will come up to this, which will be in a total hemispheric concept with the sea level, which is the base level in the marine scale. So what is the base level in case of the continent? In case of continent, there is the same base level that goes, and which finally is defined by the water table. That how this water table that will be controlling that what is the lowest level of denudation in the continental part. In the marine part, this I have already discussed. What is the water depth? What is the relative? So this is this plane, which is actually a data, and this is actually a sea floor. So when we talk about the relative sea level, we talk about the response of data with respect to sea level. That whether the data and the sea level they are approaching one another or they are going away from one another. If they approach one another, that means accommodation is decreasing and you are getting an uplift. If they are going away from one another, you are basically getting a subsidence or a rise in the sea level, and that is actually when you get the translation. So thinking of what is the relationship of this datum with the sea level. Don't think of relationship of the sea floor and the sea level, because sea floor, it is defined by the sediment, the deposition of sediment on this datum and the top surface of the depositional surface, that is your sea floor. So sea floor is not defining that whether you are basically going to a transgression or decression. It is the datum, its movement to up or down, and the sea level, its movement up and down, that basically is controlling whether you are increasing the accommodation or decreasing the accommodation. So now, we will be seeing the we came to know the definition of the base level, and we came to know that the base level and the sea level, these two are not same, because the base level, it is a function of the sea level and the energy flux on the shoreline. So the sea level and the energy flux, these two together, that basically controls the base level. And the base level is the level up to which the erosion takes place. So the erosion need not be taking place only up to the sea level, which may be the subaerial erosion, but you can have a subaqueous erosion which can go up to the base level. So now, if I get the base level curve, if I have a base level curve, is a sinusoidal base level curve. Sinusoidal base level curve. And this base level curve, that is high and low. I discussed earlier also that the absolute base level curve really doesn't matter. It is the rate of base level curve that actually matters on a coastline. The actual base level curve has no value, because the sedimentation and the rate of base level change, that basically affect how a coastline that will be behaving. So if I take the rate of base level change, this is the rate curve, rate. This is the rate of base level. Rate of base level change. So if this is positive, this is positive, and this is negative. This is positive and this is negative. Here, this is positive, this is negative. And this is the rate of base level curve. What I am doing here, I will be superimposing on this relative sea level curve, the rate of base level curve, a uniform sedimentation rate. I will superimpose a uniform sedimentation rate. That uniform sedimentation rate that I am superimposing on uniform sedimentation. So this is uniform sedimentation. Okay. So then, if I divide, I start from here. What is happening in this entire? And this is a sinusoidal base level change. And sinusoidal base level change, they are not exactly reflection of transgressive regression, but they are very closely following the transgression regression. Very closely. I will say it is not a transgression regression, but it is very closely following the transgression regression. Why I am saying? In case of what is the definition of transgression? It is the migration of shoreline landward. That is transgression. What is regression? Migration of shoreline basinward. What is base level? Base level is the lowest level of erosion. So there are two different definitions. Transgression, regression, it depends upon one definition. Base level, it goes by the another definition. But both the definition, they nearly follows one another. So if the shoreline, this shoreline, it moves landward, so definitely the base level of erosion will also move landward because the whole water level increases and base level of erosion will also increase. So these two, please remember it very carefully and keep it in your mind. I have seen there is no clarity of these things in any mind of, forget about students. In most of the scientists I have talked about, I have seen these two are people are basically mixed these two. They are not same. Transgression, regression curve, base level curve, they are not same curve. Though they look very same because their definitions are completely different. Transgression depends upon migration of shoreline. Base level depends upon the lowest level of erosion or subaqueous erosion. So subaqueous erosion curve that will follow the transgression regression curve, but that will not be exactly the transgression regression curve. Am I clear?
Yes,
See,
sir.
this course is to make these things clear in your mind. This course is not to tell you this is the definition, that is the definition, this is the definition, ye iske baad aata hai, wo uske baad aata hai. That is not my aim. My aim is to make the things clear in your mind. That what is transgression, what is base level, what is local base level, what is global base level, what is sea level, and how base level is different from the sea level. All these definitions, they are all juxtaposed and cluttered in our mind. And we do not know the difference. So when we write paper, the reviewers from abroad, they give us gali that you do not know the definition even. In our country, we do not know the definition even, that what is what. So my aim is to make you on, at least if these things is clear in your mind, then you are actually, you know half of sequence stratigraphic concept. Because most of the people do not know the definition actually. Now I come here, then what is happening in, you see, as you are superimposing the sedimentation rate on the rate and the rate of base level curve, you are actually dividing the base level curve in some subparts. Subpart. You are dividing it in some subpart. Okay. Now, what if I start from here? What you are getting here in this part? In this part, your relative sea level curve is here, but sedimentation is here. Relative curve is here, sedimentation is here. So, though your relative sea level curve, it is on the positive side. Relative sea level curve, the red curve, it is in the positive side because this is 0. Your curve is in the positive side. So what does it mean? Your curve in the positive side means you are generating a positive accommodation. Remember, be very, very clear. When your curve is on the positive side of the equilibrium line, you are actually generating a positive accommodation. But your sedimentation is higher than the rate of accommodation you are generating. Your sedimentation is always keeping pace or higher than the rate of accommodation you are generating till you reach here. So this to this part is that the accommodation positive but low, sedimentation more than equal to accommodation. Isn't it? If I call A and B, in AB sector, in AB part, accommodation is positive but low positive, and sedimentation either exceeding or equaling the amount of accommodation. That means though you are generating accommodation, you will not get any signature of transgression here, because your sedimentation is either balancing your accommodation or exceeding your accommodation. So you will not get any signature in the rock record that the accommodation was increasing. Am I clear? Though the accommodation is increasing, I will not get any signature that the accommodation is increasing, because the sediment is either equaling the amount of accommodation that is being generated, or the sediment that is exceeding the accommodation what is being generated. So that is in the rock record, no signature of increasing accommodation or transgression that will be available to me. And this is what we call, this portion what we call normal regression. We call it normal regression. Am I clear? We call it normal regression, because though accommodation is increasing, accommodation increasing at a low rate, and sedimentation is either balancing or exceeding the accommodation, giving me no signature in the rock record that the accommodation was increasing, and that is why we call it a. Okay? Now, what will happen when you are here? What is happening is when you are here? Here, your accommodation. What accommodation your accommodation generation is this. This is, and your sedimentation is lower than the accommodation. So it is BC. So in the BC, what is happening? The accommodation, it is more than the sedimentation. Isn't it? Hello?
Yes, sir.
Yes.
So the accommodation from B to C, this portion, the accommodation is more than sedimentation. This is what we refer to as, this is what, sorry, here. This is what we refer to as transgression. Transgression, when the accommodation is more than sedimentation. Then you come to A, B, C, D, CD portion, CD portion. What is happening? Again the same, what was happening in A and B, it is same thing happening in C and D. That you have, but here the base level is falling, but still on the positive side. Base level falling, but still on the positive side. And your sedimentation is exceeding the amount of accommodation. So this portion, this again becomes normal regression. Why normal regression? Because again the same logic, that the accommodation generation is on the positive side, but I am not getting that signal. I am getting signal that the accommodation is basically in a positive side up in this sector B to C, where accommodation exceeding the sedimentation. As long as accommodation is not exceeding the sedimentation, I will not get the signal that the accommodation is positively increasing. So then it is normal regression. Then you come to this portion, DE. What is DE? Here you have your red car, it has gone to the negative side of the equilibrium. It has gone to the negative side of the equilibrium, and then you are getting, this is a negative accommodation. This is a negative accommodation. Negative accommodation, what does it mean? The negative accommodation, that you are basically getting a erosion. So this portion, what we call the forced regression. What is happening? What is the difference between normal regression, what I am telling, and the forced regression? In the normal regression, the base level that is basically high, it is on the higher side from the equilibrium. There is a positive accommodation. There is no real fall of the base level. In normal regression, I repeat, this is a major thing that I am talking about, which you should be very, very careful in your mind. In a normal regression, there is no base level fall. The base level is on the positive side of the equilibrium. Only because of the higher sedimentation, I am getting a regressive signature, but there is no base level fall. But what is in a forced regression? That there is a real base level fall, where the base level is going below the equilibrium line, and so that is what we call the, so two regressions, they are different. Both are regression, both showing the regressive signature, but the controls, the signatures, finally the product of all these two, that will be completely different. So what we are getting, that you have a normal regression, and the forced regression. Then from this part, this will be again similar to this. So what I am getting, that there will be a normal regression, translation, normal regression, forced regression. There are two things that is clear from this diagram. One, that there are regressions can be of two different types. One is a normal regression, another is a forced regression. Normal regression does not involve any base level fall. It is only the sedimentation overtaking the rate of base level rise. Whereas a forced regression, there is a real base level fall. This is first. Second, another thing that is very clear, that if I consider this is a cycle, this is a rise and fall, and this makes one cycle. In one cycle, the cycle is more biased towards regression than translation. If I divide the entire thing, that you have a forced regression, normal regression, and only one place, that is translation. So the regressive products in a stratigraphic record, the products of regression, they always overtake the products of transgression. So the stratigraphically, the regressive products, they bias the stratigraphic product. They are not, because a significant part of the transgressive product, that is obliterated by high sedimentation rate, and that also gives us regressive signature. So transgressive part, that is very, very limited, and the regressive part, that is much more extensive, and that basically takes a larger share. Is it clear what I have said? Is now the normal regression and the forced regression, it is clear in your mind? What is the difference between normal regression and the forced regression?
Yes, sir.
Yes, sir.
So regression, when we talk, that there are two different regression and their controls are completely different. So we have to be very, very clear when we are talking about the regression, what kind of regression I am doing. And now, if I basically describe it in a very physical manner, what really is happening in a physical manner. in a very simplistic way, I am now talking about. In a very simplistic way. To differentiate between the two products. So this is a basin and this is another basin. Here normal regression I am defining, here forced regression. In case of forced regression, what will happen? That the sea level is falling. So this is 1, this is 2, this is 3. The sea level is falling. Okay? In the forced regression. Now, if this is happening, the base level is also falling. So the base level of erosion also falling. When this was the first sea level, suppose the base level was here, second base level here, and third base level here. So the base level is also falling. So when I will be reaching at 3,
Sir, you are not audible again.